So in this experiment what we have to do, the aim of the experiment is to plot the IV characteristics, current versus voltage characteristics of a PN junction diode in forward bias as well as reverse bias. So this is the diagram, circuit diagram for the forward bias. So battery positive should be basically connected to the P type of the diode. This is the diode, P type of the diode, and the current is positive and voltage is also positive. In the reverse bias, you just flip the battery, that's all. So, and also ammeter and voltmeter. So in the reverse bias, diode is connected, P type of the diode is connected to the negative end of the battery, unlike in the forward bias. And the current is negative, voltage is negative. So let's start with the connections here. This is the kit. Now in the exam you will be provided with the kit but without any connections. So in some of the kits what will happen, there will already be connections made, there are no connections here. So basically you have to make the connections. So by looking at the circuit diagram we can make the connections. So first let us make this connection. Battery positive is going to voltmeter positive. So I'll choose a wire with a hole in it. So I'll put battery positive, this is the battery positive. So battery positive is going to voltmeter positive. So this is the first connection. The second connection you can see, battery negative is going to voltmeter negative. So again I'll choose a wire which has a hole in it, you can see. So battery negative to voltmeter negative. So this is the connection. Then battery positive is also going to P type of diode. So battery positive, that means here, that's why I took a wire which has a hole in it. So battery positive to P side of the diode. This is the P type of the diode, there is the diode here. Then negative end of the diode is going to positive of the ammeter. So negative end of the diode is going to positive of ammeter, it's here. Then negative of ammeter is going back to the battery negative. So negative of the ammeter is going to battery negative. So I'll make the connections other way. It's going to negative of the battery. So this is the connection in forward bias. So it should work now. You can see that the voltage is rising. So now what we have to do, we have to take, so just have a look at the circuit connections once. You can take a screenshot. So this should have been here. Right. Now what we have to do, first we have to calculate the least count of voltmeter in forward bias, least count of ammeter in forward bias, and then we have to calculate, take the VI values. So in steps of, I have taken in steps of 4. Now first let us calculate the least count. So you can choose any number here. I am choosing 1. So between 0 and 1 there are 40 divisions. So from 0 to 0.25 there are 10. So 10, 20, 30, 40 divisions. So the least count is your chosen number, which is 1 divided by 40. So that's the least count. So now milliammeter, again I'll choose 10. Again from 0 to 10 there are 40 divisions. So least count of ammeter would be 10 milliamps divided by 40, which is 1 by 4. So for voltmeter I'll write 1 by 40 volts, and for ammeter it's 1 by 4 milliamps. So then what I have to do, I have to increase the voltmeter reading by 4 divisions. Every 4 divisions I have to take the corresponding ammeter reading also. So for now it is 0 and 0. Now I will increase the knob, turn the knob such that the needle is 4 divisions away from 0. So this is 4 divisions away from 0. So I'll write here 4 divisions into 1 by 40, because 1 division is 1 by 40. So 4 into 1 by 40, which is 0.1. Now correspondingly what is the ammeter reading? It's still 0. So I have to write 0. So number of divisions is 0. So 0 into 1 by 4 is anyway 0. So similarly now I have to go to the 8th division. So this is the 8th division. So that means voltmeter reading would be 8 into 1 by 40, which is equal to 0.2. Correspondingly current is still 0. So its number of divisions is 0, so 0 into anything is 0. Now let's check a random number. So now you can see that the voltmeter reading is, it's how many divisions away from 0 I have to calculate. 10, 20, 30, 32 divisions away from 0. So my voltmeter reading would be 32 into 1 by 40, whatever it is, calculate that. Now correspondingly, what is the ammeter reading? It is, you can see that it is 9 divisions away from 0. So ammeter reading corresponding to this would be, number of divisions is 9 into 1 by 4. So that is the ammeter reading. So it's 2.25 or something you will get. So basically you have to plot this later. So similarly you have to calculate for in the reverse bias also. Reverse bias also you have to calculate the least count first of voltmeter and ammeter. Then again you have to increase by 3 divisions or 4 divisions. So in the forward bias it is better to increase by 4 divisions, because you will get a nice number like 0.1, 0.2, 0.3. It will be easier to plot. Now when you plot, you have to get in the forward bias graph like this. So you will get a forward bias graph like this. I versus V you have to plot, and you have to choose a linear region. And in that linear region, if you calculate slope, which is tan theta, you will get 1 by resistance. We call this a dynamic resistance. So 1 by dynamic resistance, from there you calculate resistance. That would be your answer for forward bias. Basically you will get 1 by slope, which is dynamic resistance in the forward region. Similarly, in the reverse bias, we will get a graph like this. Again you have to choose a linear region, calculate slope, you will get 1 by resistance, calculate the inverse of that, you will get resistance in the reverse bias. The result is that the resistance in the reverse bias is much greater than resistance in the forward bias. Usually this will be of the order of mega ohms, and this will be of just ohms. Maybe this is 50 ohms, this is some 1.6 or whatever, this doesn't matter, the order is mega, 10 power 6. So that will be your result. So basically you have to plot, and you have to show that the resistance in the reverse bias is much greater than the resistance in the forward bias.